Welcome back. How did it go with the remove method? It should be fairly easy since we got the insert method, right? All we need to do is first check the parameters. And we might want to check whether the index is a positive number, whether the index is higher than the length, but that's something we've already talked about. So let's get to the meat and potatoes, the main part of remove. All we need to do is once again, get the reference to our leader. So that is if we want to remove, let's say 99. So that is index of 0, 1, 2. In that case, we want to make sure that we remove the 10 to 99 pointer and instead point 10 to 5. And because of how memory works in garbage collected languages like JavaScript, as soon as we remove that reference, 99 is going to get deleted. So all we're saying now is remove this pointer and then just update this to point to this list, and this gets deleted. I hope that my little diagram there makes sense. Let's code this out. Well, we first find the leader just like we did in our insert function by using this dot traverse to index. So I'm going to say this dot traverse to index, index -1, and we have the leader. Now, we have the leader, and we can point 10 to now point to 5, but we need a reference to this 5. And the way we get that reference is to say const unwanted node, that is the node we want to delete, is going to have leader.next. That is, the unwanted node is going to equal leader.next, which is 99. And we got that variable, so we can do leader.next to equal unwanted node dot next. So we grabbed the leader, and then we said, this node that I don't want, I want to grab it here by using leader.next, and then make sure that we get the pointer, that is 99 to 5, which is unwanted node.next, which equals to 5, the 5 node, to now be pointed from leader.next. And of course, so we don't forget, we have to decrease the length because we're removing a node by doing minus minus. And we can just return this dot print list here. That wasn't too bad, was it? Let's go down here and make sure this works. I'm going to say that we want to my linked list dot remove at index of 2. So let's remove the 99. I'm going to run this. Look at that. We've removed 99. If I run remove again at index of 2, that is to remove 5. Oh, not print list, remove. And we click run, 5 gets deleted. Very, very cool. And once again, we know why delete is an operation of O of n, because we have to traverse to index. And going back here, we now have a better understanding of how this diagram works. If I remove the tail, we have to traverse through everything, one by one, until we hit the tail, and then just remove it, and there we have it. And I encourage you to play around with this animation a little bit more, having our linked list implemented. There are other methods that we can add to it, but these are the main ones of linked list that you can see. And this should give you a better idea of how we calculate big O notation with linked lists and where some of the drawbacks are. I mean, you can explain data structures for a long time, but without actually coding it yourself, it's hard to see why some operations take longer than others. And linked lists are very popular in interview questions. And now you have the tools to build your own linked list in a language that doesn't even have it natively, like JavaScript. Well done getting this far. In the next video, we're going to introduce you to the second type of linked list that I mentioned at the beginning. Up until now, we've created singly linked lists. But there's also a doubly linked list. What does that mean? For that, I'll see you in the next video. Bye-bye.